Algebra I 8.4b, we've been talking about systems of equations, and here's some more word problems. If we have 4 pears and 5 apples that cost $3.56, and we have 3 pears and 4 apples that cost $2.76, find the cost for 1 pear and the cost for 1 apple. So if you look, they had 4 pears and 5 apples, and that was $3.56. Now 3 pears and 4 apples, one less of each, is $2.76. So that's our two equations. We have 4p, we're going to let p be pear and a be apple. So we have 4p plus 5a equals $3.56. And our second equation is 3p plus 4a equals $2.76. Okay? So 4p and 3p can meet at 12p. So we're going to multiply this 4 and all of these other terms by a 3. And because we need to make a 0 pair, we're going to multiply this one by a negative 4 to get to 12. Okay, so it'll be at negative 12. So now we've got 12p plus 15a equals $3.56 times 3 is $10.68. And now we're going to multiply each of these terms by a negative number. So we have negative 12p plus minus 16a, because 4 times negative 4 is negative 16a. And then we multiply this by negative 4, and we get negative 1104. Now we can see that this created a 0 pair, didn't it? Right here. So that's canceled out. That's gone. And we end up with just a negative a is equal to a negative 36 cents. So we can drop the negative sign from each side. All right. So we know that 1 apple is 36 cents. Now, all we have to do is take this 36 cents and plug it into one of the original equations, like this one on top, and we end up with 4 pears plus 5 times 36 cents is equal to $3.56. 5 times 36 cents is $1.80. We did some math on the side. Now that created a 0 pair, didn't it? So now we've got that 4 pears, 4p, is equal to $1.76. We divide each side by the coefficient 4, and we find out that the pears each cost 44 cents. We know an apple is 36 cents and a pear is 44 cents. See? Just very slowly, step by step, okay? This is the part that is going to cause you the most trouble, because you need to find a place for the terms to meet to create a 0 pair. And we could have used this one, and where can a 5 and a 4 meet? They can meet at 20, right? So we could have multiplied this by a positive 4 and this by a negative 5, and then all the terms on the second one would be multiplied by negative 5, and all the terms up here would have been multiplied by positive 4. That way they would have had a plus 20 and a minus 20, and we could have eliminated the a and solved for the p, see? So I just chose this because it was right up front, and 12 is easier to deal with than 20, okay? Let's look at another one. Here's another age one. Rose is 18 years older than her son, and she was 3 times old as he was 1 year ago. How old are they now? So we need to write two equations for our system of equations. We're going to let r equal Rose's age and s equal son's age. And it tells us right in the words, r equals 18 plus s. She's 18 years older than her son, so her son's age plus 18 is her age. So that's our first equation. She was 3 times as old as he was 1 year ago. So that means her age now minus 1 year was equal to 3 times her son's age minus 1. See? Her son's age minus 1 times 3. So that's our second equation. Now we need to simplify this one because we've got some distributive property going on. And that becomes 3s times 3s minus, see, we're doing distributive property, here's the 3s, minus 3 times negative 1 is a negative 3. Now we can add 1 to each side because of this minus 1. We can plus 1 to each side and create a 0 pair and get the r by itself. So now we have r is equal to 3s minus 2, see, because negative 3 plus 1 is negative 2. Now we can substitute the S plus 18 to stand for Rose's age. We'll just use this entire thing to represent R, because it says it's equal to R, so we'll use it as R. So now, instead of R and the S minus equals 3S minus 2, we plug in the S plus 18 as the R. So now we've got S plus 18 equals 3S minus 2, see? So this R got changed into this S plus 18, see? Now, we've got a minus 2 over here, so we can add 2 to both sides to create a 0 pair here and get rid of this. So now we've got S plus 20 equals 3S. So we need to isolate the S to one side, so we can take away an S from here and an S from here, create a 0 pair here, right? Now we just have 20 equals 2S. We divide each side by the coefficient 2, and 20 divided by 2 is 10. This becomes 1S because our buddy, the invisible one, that identity property. And we know that S is equal to 10. So we know her son's age is 10 now. Now what we have to do is plug this in to the first equation. R equals 18 plus 10. Instead of 18 plus S, or S plus 18, we just put 10 in the place of S. So we know that her age now, Rose's age now, is 28. So we have our solution. The son is 10 and the Rose is 28. And a year ago, when she was 27 and he was 9, she was 3 times his age. So that works out, doesn't it? All right, here's our last one. Lisa bought 10 packages of paper cups for a party, and a pack of 50 12-ounce cups cost $1.80, and a pack of 50 16-ounce cups cost $2.40. Now, she paid $21.60 before tax. How many packs of each cup size did she buy? So we need to write a system of equations. We're going to let T stand for the 12-ounce cups, because T is the start of 12. And we're going to let S be the 16-ounce cups, because 16 starts with S. So we have T and S, okay? So to write our equations, we have $1.80 plus $1.80T. $1.80 for 12-ounce plus $2.40 for 16-ounce, that's 240S, is going to equal that $21.80, that total. Now we need to remove the decimals, and we can do that by multiplying terms by 100. So if we multiply each term by 100, it's going to move that decimal place to the back of each number, isn't it? It's going to move them back here. And then our second equation is that T is 10, because she bought 10 packages. 10 take away T, the 12-ounce cups, is going to equal the 16-ounce cups, right? Does that make sense to you? She bought 10 packages. This stands for 12-ounce. This stands for 16-ounce. If her total was 10, we could have also said S plus T equals 10, couldn't we have? But I decided to go in the subtraction route, all right? Because that'll tell us what S is. And then we can solve for S and use 10 minus T to represent S, can't we? So we're going to substitute the 10 minus T for S, all right? That's why I wrote it as subtraction, all right? So the decimals are gone. We have 180T plus 240S equals 2,160. And we're going to substitute this 10 minus T in place of the S in the equation. So instead of having 140S, we have 240 times 10 minus T, all right? Because we substituted it. So now we need to do distributive property with this part of the equation. And that is going to get us 2,400, because 240 times 10 is 2,400, minus 240T, all right? So now this is our new equation right here. After we do this distributive property, we get this. So now we have like terms. We have 180T and we have 240T. When you have 180 and take away 240, you get a negative 60T. So now the math from this one and this one gave us this, okay? So now we've got 2400 minus 60t equals 2160. We can take the 2400 away from each side to isolate this t. It's going to create a zero pair here. And we're left with negative 60t is equal to negative 240. Because 2160 minus 2400 is a minus 240. Now we can divide each side of this equal sign by this coefficient negative 60. We got our buddy the invisible 1 for identity property, and that leaves us with a t on this side, and negative 240 divided by negative 60 is 4, because 4 times 60 is 240, see? So now we know that the 12-ounce cups, there's 4 packs. We just plug that into our subtraction problem. 10 take away 4 equals S, so S must be 6. So there must be 6 16-ounce packs and 4 12-ounce packs, okay? So that one was a little more involved because we removed the decimals and we had to come up with the system of equations, and we had to do some distributive property when we substituted 10 minus t in for the S. Then we had to combine like terms, and then we solved for t, and then we plugged it into the equation, okay? Our next video is going to be 8.5, and we're still talking about systems of equations, and we're going to talk about motion problems. And if you want links to any of the previous videos, they're going to be in this description. And there's also going to be a link to my Grade 8 Math System of Equations playlist, because I've been saying there's a lot of videos in the Grade 8 Math playlist that are Algebra I and will help you. And I might explain things differently, and there might be other examples. And I hope this was helpful, and I'll see you there. Bye.